This is the video for 8.1 and we are talking about polynomials. A polynomial is the sum or difference of multiple terms. And it's very important that you understand what a polynomial is not. A polynomial cannot have division by a variable, so in other words, the variable cannot be in the denominator, and a polynomial cannot have a fractional exponent or a negative exponent. So in other words, the exponents that are in polynomials must be positive whole numbers. In Algebra 1, we are going to be working with 3 different types of polynomials. A monomial is a polynomial with 1 term, a binomial is a polynomial with 2 terms, and a trinomial has 3 terms. Remember, a term is separated through addition or subtraction, and a polynomial can have more than 3 terms, but a polynomial cannot have an infinite number of terms. That's very important for you to remember. A polynomial cannot have an infinite number of terms. And finally, standard form. Your answers always need to be written in standard form. Standard form of a polynomial is when the terms are ordered from largest exponent to smallest exponent. So I have 2 examples here so you can see what standard form is and what standard form is not. Example number 1, finding the degree of a monomial. The degree of a monomial is the sum of the exponents of the variables. So in the first example, 5x, that is a first degree monomial, because the exponent here is 1. The next example is a 5th degree monomial because the degree is the sum of the exponents of the variables. And whenever you have a constant term, the degree is going to be 0. And here's why. Because the degree of a monomial is the sum of the exponents of the variables. So if we have a constant term, we can say that the sum of the exponents of the variables is 0. So go ahead and hit pause and find the degree of these 3 monomials. And here are the answers. The first one is a 2nd degree monomial, the next one is a 5th degree monomial, and the last one is a constant term, and so that has a degree of 0. Remember, whenever there's no exponent written, always write in a 1. Example number 2. Now we are going to name and classify polynomials. So in lesson 1 in chapter 8, there is some memorization, but it's not too difficult. You do need to memorize the names for the different degrees of polynomials. And you can have a polynomial that has a degree higher than 5, but for Algebra 1 right now, that's all I'm going to ask you to memorize. So the degree of a polynomial is the same as the largest exponent in the polynomial. So when naming polynomials, think of it this way. You have to give it a first and a last name. The first name is going to tell you the degree, and the last name is going to tell you how many terms there are. But you have to combine your like terms. You cannot determine how many terms there are in a polynomial until after you have combined all of your like terms. And remember, you always write your answer in standard form. So you always put the term that has the highest exponent first. So in this first example, what did I do? There's nothing I can combine. So I just went ahead and I put it in standard form, and I can see that the largest exponent here in this polynomial is 2. So I go over here and I say, well, a second degree polynomial is called a quadratic, and we're going to be learning about those next chapter. And it has 2 terms, so this is going to be a quadratic binomial. In the next example, I cannot name this polynomial until after I have combined all of my like terms. And then I put it in standard form, and I can see that my largest exponent is a 3. So this is a third degree trinomial. So I'm going to call this a cubic trinomial. And it's a trinomial because after I have combined all of my like terms, there are 3 terms. So go ahead now and hit pause and name these 2 polynomials. Remember, combine all of your like terms, put it in standard form. The largest exponent is going to tell me the degree. You have to memorize the naming system for the degrees, and then you give it a first and a last name. The first name is going to tell you the degree, and the last name is going to tell you how many terms there are. So this is a quadratic trinomial because after I put it in standard form, I can see that my largest degree is 2. So if I look at my naming system chart, I can see that this is a quadratic polynomial, and I'm going to call it a trinomial because it has 3 terms. And in this example, I have to combine my like terms, and then I put it in standard form, and I can see that this has a degree of 4. So on my naming system chart, a degree of 4 is a quartic, and this is a trinomial because it has 3 terms after I've combined all of my like terms. Example number 3, adding and subtracting monomials. When adding or subtracting monomials with the same variable combination, you add or subtract the coefficients and you keep the same variable combination. So remember, you can only combine like terms that have the same variable combination. So here I have 3x squared plus 5x squared equals 8x squared. And I want to make sure you understand why you keep the same variable combination. Because think about what this is saying. This is saying I have 3x squared plus 5x squared. Well, what happens once I add them together? Now I have 8x squared. So that's why when you're adding these together, you are keeping the same variable combination. So in the next example, 4x to the third times y minus 1x to the third times y is going to be 3x to the third times y. Remember, if there's nothing there, it's a 1. If there's no coefficient written, the coefficient is 1. Now go ahead and hit pause and add or subtract these monomials. And here are the answers. I'm going to add or subtract the coefficients, and I'm going to keep the same variable combination. But remember, if they do not have the same variable combination, you cannot combine them. And finally, example number 4. We're going to add or subtract polynomials. So let's look at the first example here. We're adding two polynomials. I'm taking this polynomial and I'm adding it with this polynomial. So I'm combining polynomials. Because of the associative property, I can drop the parentheses and just start combining like terms. But be very careful that you don't lose track of what you're doing. So when you're combining like terms, cross off the terms as you go so you don't lose track of what you're doing. So for example, I'm going to take a negative 7.1 x squared and I'm going to combine that with a positive 21 x squared. I'm going to cross it off and now I have 13.9 x squared. So cross off the terms as you combine them so you don't miss something, because these can get very long and very complicated. And remember, your answer always has to be in standard form. Okay, but now look at the next example. Now some books tell you to set the problem up vertically and to subtract, and even your book does. But you have to trust me. Please don't do that. I know where this is going in Algebra 2 and college algebra, and you have to trust me that you have to develop this skill. So remember, if there's nothing there, there's a 1. So think of it this way. What I'm doing is taking this negative 1 and I'm distributing it to each term inside the parentheses. I'm multiplying this negative 1 to this polynomial. I'm taking this entire polynomial and I'm multiplying it by negative 1. Because if I was to just cut off this half of the polynomial, you can see what I have. I have this entire, or excuse me, if I were to cut off this polynomial here on the left-hand side and all you had was what's over here on the right, you can see I'm taking this entire polynomial and multiplying it by negative 1. Because order of operations say you have to do the multiplication first before you do addition and subtraction. So do your multiplication first, and this is what you end up with. Then go ahead and deal with the other polynomial and just bring it straight down. So pause the video to make sure that you fully understand what I did. It's very important that you develop that skill. And then after I went through and I distributed out this negative 1 to each term inside the polynomial, I went ahead and I started to combine all of my like terms, and then just like I did up here, go through and combine all of your like terms. Don't forget to cross off the terms as you combine them so you don't lose track of what you're doing, and then make sure your answer is in standard form at the end. Okay, so go ahead and hit pause and work out these two on your own problems. And here are the answers. Because of the associative property, I can just mentally drop these parentheses and just start combining like terms. Cross off the terms after you combine them so you don't lose track of what you're doing and you don't miss something. And then here I have to distribute out this negative 1 because this is saying negative 1 times this entire polynomial. And I always have to do multiplication first before any addition or subtraction. So I distributed out my negative 1. And then I went through combined like terms, making sure my answer is in standard form.